I'd like to welcome you to this Winemakers Research Exchange virtual sensory session. Today, we are talking about pre-bottling decisions that impact post-bottling wine quality. My name is Joy Ting, and I'm the Research Enologist for the Winemakers Research Exchange. And I'm joined today by Lee Hartman from Bluestone Vineyards and Kirsty Harmon from Blenheim Vineyards. Today, we will be looking at two experiments. The first one, you had some wines that you should have received by UPS. We'll talk about that experiment first. The other experiment is an ongoing data-driven project that we think is providing some information that might be useful now before you go into bottling season. Both of these experiments are ongoing and will continue to age and will continue to look at those wines as they age over time. So we'll update you with any new information that comes in along the way. So before we really jump in, though, I do want to kind of have an idea of where you all are coming from. So the first experiment that we're going to look at today is one looking at different closure types in rosé. But before we jump in, I'm curious to know what kind of closures you all are currently using. So I think Jen is going to launch a poll here. And if you would, please fill out the poll questions for us. So we're just asking, what types of closures are you currently using on any of your wines? That first one is a check all that applies. So if you're using multiple different types, just go ahead and check multiple different types. Then, which is the one that you use the most? So if you're using mostly one type with a couple of smattering, let us know if there's one that you really favor. We'd also like to know if you've changed your closure types in the last couple of years. So if you've made a change, what is it you've moved away from? And if you've adopted any new closure types in the last couple of years. So go ahead and fill that out, and we'll take a look at the answers in just a minute. We still have a few more answers coming in, so just another maybe 30 seconds or so. I can see how many people have voted, so if you can, please do vote. Okay, last chance. Okay, Jenny, you want to go ahead and end the poll there? I think we have a couple folks that are like two folks in the same thing, so we won't get all of the.
All right, would you like for me to share the results?
Yes, please. There we go. Okay, so it looks like a lot of folks are using natural cork. We also have screw cap and agglomerated cork, so that sort of Diam version. Those seem to be the highest percentages there. We have some folks still that are kind of using various versions of synthetics, which we'll look at a little bit today. Those 1+1s are still in there, so that's interesting. And then we have one other, and unfortunately, we didn't have the option to be able to write in what that other one was. So if you're the one with the other, and you can put that in the chat, that would be great. But if you want to be shy, then that is your choice. Okay, so then if we look at most common, that's very interesting. We have 24% of folks are using natural cork as their most common. 33% have screw cap as their most common option. That's very interesting. Followed closely by agglomerated corks and again, those synthetics. Most of you are sticking with your choices and you're not moving around too much. But for those of you that, let's see. So let's see, what type did you replace? I don't think I can, Jenna, can you see the answer if somebody has replaced a kind of cork? What kind of cork did they replace?
Yeah, so, okay, let me see. Hang on one second.
We never know how these polls are going to look until we actually launch them with a group. So thank you for bearing with us on that.
So I have one response. I will be moving away from synthetics to aglo next month. Another participant said screw cap, and another said some clients moving to screw cap, some staying with cork.
Okay, and that's so for clients, yeah, sometimes it's not the winemaker's choice, but it's a packaging kind of decision as well. And then what about this one for adopting new types? What are the new types coming on?
So we have natural, aglo, aglo. And one person says we had a little bottle that needed a bar top.
Okay. Oh, that sounds like fun. So there's always the interesting ones along the way. So those results are a little bit different from what Wine Business Monthly found. In 2021, Wine Business Monthly did a cork survey, and they found that 70% of the winemakers that they pulled used natural cork in at least some of their wines, and about 54 used cork in all of their wines. They found that 37% had switched sometime recently, and most of those were moving away from natural cork, usually because of the concerns with TCA. Later in that same survey, most of those were moving toward a screw cap kind of closure. But of course, there's lots of different things that you kind of think about when you think about what kind of closures to add in. So that brings us to our first experiment for the day, and that is one that was done by Lee Hartman from Bluestone, looking at different closure types in rosé. So Lee, thank you for being here today. Let's just start off. Why don't you tell us just a little bit about your rosé itself? What are you making it from? What are your winemaking goals for that wine?
Sure. Thanks for having me. So for our rosé, we've been making it now with it's 100% Chambourcin. And if you've ever tried to make rosé with Chambourcin before, you might know that it has to be whole cluster pressed, which is what we do. Several years ago, I made a white Cab Franc to blend into it to kind of brighten it up a little bit so it wasn't so dark. But then we ended up canning that stuff. So I guess there's another closure for you. But anyway, but yeah, so it's this dry, very juicy 1984 hot pink color when you look at it in our Burgundy bottles, in our clear Burgundy bottles. But yeah, so it's grown here on the property. We make a boatload of it. If anybody wants any shiners, let me know. And yeah, it's all tank fermented. We also have done experiments in the past where we've pulled out of the racking port during fermentation and done a pet nat with it before as well.
Right. So what is the closure that you usually use on this wine?
For our rosé, we typically use screw cap.
Okay. And
Yeah,
what were the other closures that you tested during this experiment?
So we did aglo corks and Noma corks as well. We've been using Noma cork on a lot of our wines for the last several years. After we had some issues with cork taint with just a regular old cork, and so we wanted something that their advertising always talks about how it has no carbon footprint, or it's net zero carbon emissions or things like that. So we thought we'd give it a try. One of the challenges we've run into with that on a lot of our other bottles, also reds and whites and other things, is those things can be really hard to pull out of a bottle. And so my tasting room team lets me hear about it. So we are looking at other options of what works best for the wine, what works best for our team and also for our customers.
Right. Yeah. And then one other question about the wine before we jump into the experiment too much. What is the kind of normal shelf life of this wine? So when would you normally be releasing it? How long after bottling are you normally releasing it? And how long will it stay in your warehouse before you kind of sell out of it?
I will need to look at when we started selling it. I think so. We bottled it this past December, so 13 months ago. And I think we released it the following spring. We are still selling it, not quite a year later, but we should be selling out of that this summer.
Right. Right.
Yeah.
Okay, so let's go ahead and take a look at the experiment itself. Let me see if I can get back here. There we go. Okay, so So as Lee said, this was an experiment with bottling in his rosé. And again, there were 3 different closure types that were involved here. The screw cap closure, which is the standard protocol, an Amarim Nutra cork, which is a version of a micro agla cork, and then the Noma cork, which is a sugarcane based cork. You can see a little bit about the chemistry of the wine when it went into bottle. In most cases, when we do these experiments, it's the winemaker who does all of the methodology. And so usually the winemaker is talking about this. In this particular case, all of the methods occurred on bottling day, which means that Lee was very, very busy that day. But it was something that was pre-scheduled. And so I was able to go and actually do the sampling myself. So I'll go ahead and talk you through what we did on that day in terms of how we set up the experiment. So all of the wine that was involved in the experiment, it all came from the same bottling tank itself. Lee bottles with wine and beer supply, so that went through the wine and beer supply mobile bottling line. And then for each of the cork types, after 28 cases had gone through, I started to pull bottles to take samples. The reason we waited for about 28 cases is it's kind of enough time to get enough of the wine sort of through the line well, we'll see in a minute, but we thought in order to get it through the line before, after any stoppages, it's sort of kind of the first time you would start to do some QC on the line if you were normally monitoring dissolved oxygen. For each of the cork types, I would take 3 bottles. I would take 1 bottle, bring it back to the lab, measure dissolved oxygen and temperature, and then I would go back into the cellar and take the second bottle. And I did that for 3 different bottles of each cork type. The reason we did it that way is just to kind of get a sampling of what was happening over the course of maybe about 15 or 20 minutes on the bottling line. There were 200 cases that were actually bottled for each of the different closure types. And I'm sorry, I forgot. We also took 2 cases of wine off of the line at that time when we took the initial samples in order to have those for chemistry samples later and for the sensory samples that you guys just tasted. If we look just a little bit more at those 3 different closure types, I pulled this from the Wine and Beer Supply website. Those are the ones that the folks that were supplying these corks. And I did add in the information on natural cork in there just as a reference point, since it's one that most of us are familiar with. So for each of these, what you can see is, first of all, the cost is lower for each of these closures than it would be for natural cork. And that is a consideration, I think, especially for affordable wines, trying to say, can we get that cost of goods down just a little bit? As Lee said, the Noma cork is made from a renewable plant-based polymer. It's derived from sugarcane. So throughout our session today, I might call it the sugarcane cork as much as anything else. And then the Nutra cork, again, is that sort of micro agglomerated cork that would sort of be the same type of a setup as what you would look at. It may be a Diam cork. All 3 of the closures that Lee was testing, those are all sort of TCA-free versions of wine closures, which is another thing I think folks are thinking about. When we think about another one of the differences between these closures, though, is the oxygen transmission rate. And when you kind of see that here, you can see that for a lot of these, they sort of list the initial, there's sort of 2 different things. There's what happens in the first year and then what happens afterwards. And that really has to do with this idea with our closures that they really bring oxygen into the bottle in 2 different ways. So the first one is just what happens when it's initially put into the bottle. So when you're putting for example, a natural cork into the bottle, there's lots of different cells in that cork, and they all contain atmospheric gas. So a lot of that some of that is oxygen. So some of that will eventually equilibrate into the headspace of the bottle itself. So as you can see, the screw cap closures themselves don't really bring very much there. There's just not a lot of oxygen hiding in the liner of the screw cap. Whereas with the natural cork, you might have a much higher number there. And then the synthetic cork, which for us would be that sugarcane cork, you also have a higher incidence coming in initially into the bottle. But then you can also see sort of the slope of these lines over time. After you get past about 6 months, that initial oxygen release has kind of been dealt with by the wine. And then you kind of start to see what the oxygen transmission rate of that closure might be. So again, you can see that for the sarin tin screw cap, which is the mostly impermeable kind of screw cap, you have almost no oxygen coming through afterwards. And you can see again that the micro aglo cork also has a very flat line, as does the natural cork. There's just very little oxygen that's coming through later on. Whereas with the synthetic, you can see that there is quite a lot of oxygen transfer that continues to happen over time. The Saranex liner, which is analogous to the screw cap that Lee used, you can see it does allow some oxygen transmission over time as well. So if you're looking at things, let's say at about 12 months, which is about where we are in this particular experiment, we would think that our micro aglo and our screw cap kind of at this point, at least theoretically, would have a similar amount of oxygen that's come in, whereas that synthetic most likely has had more oxygen that's come in just through the closure. But when we think about these things, we do need to keep in mind that there's other things that are contributing to oxidation in that wine. So we just talked about the oxygen initial release, but then there's also the things that are sort of starting in the bottle when you do your bottling. So the other two components of that would be the headspace, the oxygen that's present in the headspace, and the oxygen that's dissolved in the wine. So that headspace oxygen, basically there's lots of things that, well, first of all, the headspace oxygen is going to depend on the fill level of the wine, but also how much space your closure takes up. So if you have a cork closure, you actually have less headspace than if you have a screw cap closure, where you have more headspace, simply because you're not taking up that space that the cork displaces. All of the different bottling lines have different ways that, or have QC in place to deal with that. I did correspond with Dave from Wine and Beer Supply about what they're doing on their line in order to limit headspace oxygen. In their case, they are pulling a vacuum in the bottle and then sparging that bottle before they fill it with wine. So sparging with neutral gas like nitrogen. After the bottle is filled, they're also sparging the headspace before they apply the closure. And when it's a cork closure, they actually pull a vacuum before they put the cap in. They're also applying nitrogen to the sort of the top of the filler bowl. So as that sort of goes up and down, they're kind of sparging that on the top as well. All of those things to try to limit the oxygen coming in. He also mentioned that several wineries do push with gas through the lines and the hoses before they open the tank itself. And that also helps to kind of limit some of that oxygen going in. Even with all of that, the Australian Wine Research Exchange did a survey many years ago of all these different components that are happening during bottling. And what they found is that about 60 to 80% of the atmospheric oxygen can kind of be displaced by all of those different things. But in the end, 60% of the total package oxygen was still coming from that headspace oxygen. So when we kind of think about managing some of the quality control measures that are going through the bottling line, it's important to keep that headspace oxygen in mind. Then that other piece is the dissolved oxygen that's in the wine itself. Dissolved oxygen wine has mostly to do with the things that you're doing pre-bottling. So it is possible to kind of measure that in your bottling tank after you're done moving the wine around, because obviously every time you move the wine around, you have the opportunity to pick up some oxygen. But there are some parts of the bottling processes that introduce oxygen as well. So again, you're still moving wine through hoses, you're still going through a filter. Still important to kind of keep everything as inert as possible if you want to be limiting oxygen in your bottle. A good rule of thumb, if you are managing dissolved oxygen along the way, is that in your bottling tank, it's best to have your red wines have a dissolved oxygen less than 1 milligram per liter. In most cases, that's pretty easy to accomplish because red wines tend to consume a lot of oxygen with the phenolics in the wine. White wines, it's a good rule of thumb to have those less than 0.5 milligrams per liter. Unless you're actively managing that, it's pretty hard to get to 0.5 milligrams per liter because, again, the white wines just don't consume oxygen as easily. So they're more likely to hold on to the oxygen that they do pick up. The other thing with this in terms of quality control, again, if you're trying to limit that, is that it has been shown that when the line is moving slowly or when you have lots of interruptions, you are more likely to have more dissolved oxygen pickup as you go along. So we talked a lot about oxygen in the bottle, but the other thing that might affect the sensory characteristics of wine that has to do with closures is really that, oxygen is not the only thing we need to think about. A lot of times, the aroma compounds in the wine can get oxidized and give us nutty flavors or bruised apple. But there's also aroma compounds in the wine that can, in the bottle itself, when there's very little oxygen present, can actually take on more of a reduced state. Some of those components then can give us aromas that we don't really want. So there are studies that really just show that some amount of reduction might not come out as reduction, but just sort of seems like lack of aromatic expression. But if you kind of keep going to a real reduced state, you might pick up some things that are more like the cooked vegetables or canned vegetables, or even all the way to like a methane or a sewer gas. So again, when we think about this with Lee's experiment, we want to say, did we have to worry about oxidation or think about what's the impact of oxygen, but we also have to think about what's the impact of the lack of oxygen. And we do know that certain varieties of grapes produce wines that are a little bit more prone to reduction. So you might think about like Sauvignon Blanc or Syrah might have some of those characteristics. And I would say that probably Chambourcin does as well. So we probably do want to think about that, especially with some of those varieties. And then lastly, before we jump into data, there are some other just like sometimes the closure brings some of its own kind of aromas. There are some things that can kind of come from the closure into the wine. And then there are some closures that will actually absorb some of your aroma compounds onto the closure itself. The WRE website has a much more complete list of these sorts of things if you really want to get nerdy about the different things that can be adsorbing and desorbing and all of those aroma compounds. There's a big table on the WRE website that you can check out later on. So with that, as we were sort of running Lee's experiment, we tried to capture as many data as possible that might help us to be able to track this as we went along and make some sense of what we saw. So first of all, we did look at the dissolved oxygen during bottling. So the graph that I'm showing you here, most of the graphs that I'm going to show you are sort of all in the same arrangement. So I'll kind of give you the lay of the land, and then we can delve in. So if we do have a tank sample or an initial sample, that'll be the first one. The yellow lines are always going to be representing what happened in the bottle that was closed with screw caps. The green are always the Noma cork, and I made the green the Noma cork because that reminds me that it's that zero carbon footprint kind of cork. And then the third one is the Nutra cork, and again, that's that micro aglo cork. So here, if we looked at the dissolved oxygen at bottling in the tank itself, it was just over a dissolved oxygen of 1. There's not real clear guidelines on rosé, but we tend to sort of follow what the white wine recommendations would be. So if a white wine recommendation is about 0.5, we are above that. But again, unless you're sort of actively sparging inert gas in there, it's going to be really hard to get that low. As things went through the bottling line, we do see that there is a certain amount of pickup here, although that pickup was really quite low. For the most part, a good rule of thumb is about 0.4 grams per liter, or sorry, milligrams per liter of dissolved oxygen pickup on the line. This was well within that, with the exception of that one first bottle of the Noma cork. So you might sort of look and see, well, that one looks like it's kind of out of the norm. And I would say that this kind of illustrates a point that we were making before, is that one of the things that can increase the dissolved oxygen is if you have a stoppage on the line. In this particular case, the screw caps were bottled first, and then we had to stop for a little while in order to replace the screw capper with the actual corking mechanism on the line. And so there was sort of a longer stoppage between the screw cap and the Noma cork than the Noma cork and the Nutra cork. We did wait again for about 28 cases to go through, but as you can see, that still wasn't quite enough time to get all of that cleared out. The other thing you can see here is the temperature. So the temperatures are the little numbers that are at the end of the columns there. Those are all in Celsius. If you speak Fahrenheit and not Celsius, these are ranging between 43 and 47 degrees Fahrenheit. That is pretty cold. I think, Lee, you can correct me if I'm wrong here. I think this was a bottling that sort of happened a little bit faster than was originally planned. And so it had just come up, the wine had just come off of cold stabilization when it was bottled. So in that case, it was still pretty cold. We do need to think about, again, the colder the wine is, the more likely it is to pick up some oxygen every time it's moved around. It's just a little more susceptible to that. But in general, we can see that we had pretty consistent sort of dissolved oxygens within these bottles right immediately after bottling. Once we let this wine age for a while, one of the ways that we can sort of determine oxidation over time is by looking what's happening with the sulfur dioxide in the wine. So in this case, the wine started with a free sulfur that was above 50, so it was very well protected at the time that it was bottled, and a total sulfur of about 148. When we look at these numbers, we're going to look at a lot of free sulfurs and total sulfurs today. We kind of want to, there's a reason I'm showing both of them. So the free sulfur is going to tell us sort of how much of that antioxidant property we have left to protect the wine as it continues to age. For white wines, the general rule of thumb for the antioxidant property is to have your white wines above about 20 milligrams per liter or parts per million. In this case, after aging all of Lee's Rosé after 1 year, we're still well within that range. But because of the fact that free sulfur is kind of a little bit hard to measure in the sense that it can bind very loosely to certain components in the wine and measure like it's free when it's really not free. Gavin Sachs has suggested that if we want to look at oxidation over time, total sulfur is a better measure of kind of the overall kind of summation of oxidation over a longer period of time. So if we look at the total sulfurs here, those are the numbers at the end of the columns again. This wine started with a total sulfur of about 148, and it lost about 33% of its total sulfur in the course of this first year of aging. We can also see that the Nomocork had lost more total sulfur than the other two closures. And if you think back to that, that diagram that we saw before, that kind of makes sense with what we would expect. We would expect that at this point, that Nomocork, our synthetic cork, has had more oxygen coming in, binding up and converting some of that sulfur dioxide in a way that that is sort of depleting over time. And so in that way, we can sort of, that makes sense with what we would expect with that higher oxygen transmission rate. We can also see that the other two closures are pretty much the same at this point. And again, that's consistent with what we thought we would be expecting there. So at this point, in terms of oxidation, it does look like Lee's wine probably isn't suffering from any of those kind of oxidative measures in that first year. Now, again, if that's around in the warehouse for another year, which we will continue to age it in the WRE office, we'll see how much that actually continues to deplete as we go along. The other thing we did want to look at was color. And a lot of times with wine, we don't really care about the color, but color is really important in rosé. Studies actually show that consumer liking or consumer preference for rosé is more driven by color than by aroma or flavor, which is disheartening as a winemaker, but unfortunately probably true. So when we look at color, there's a couple of different objective measures we can look at, but that's also where your sensory impressions become really important. So when we measured color for this, we measured the absorbance at 3 different wavelengths. The absorbance at 420 tells us something about how yellow the color is. At 520 tells us something about how red the color is. And at 620, it tells us something about how blue the color is. If we look at sort of the overall color intensity, we can see that the Nomocork seems to have more intense color than the other two. That may very well just be a function of the fact that it has less free sulfur out there. So those of you that make rosé realize that when you do a sulfur addition to your rosé, it kind of bleaches out for a little bit. Sulfur dioxide will kind of bind to some of those color molecules and bleach them temporarily. As that sulfur dioxide is quenched with other things and lets out a little bit, then sometimes your color comes back, and that might be part of what we're seeing there. But if we look at those individual numbers, we can see that we do have an increase in the values at each of those sites. So we do have an increase at 520, probably because some of our anthocyanins are losing their bound sulfur and therefore becoming a little more red. But we also have an increase at 420, and that's our measure of browning. So the other thing we can look at as a measure of browning is that ratio of 420 to 520, and that's what we call the hue. If you look at the number here, the hue has shifted a little bit here. So the wine that's bottled under Nomocork does have a little bit browner hue than the other two at this point. But again, the most important thing is whether or not you can determine that, whether that's something that we can actually see or not. And that's where your sensory impressions become really important. So before we jump in and talk about your sensory impressions, I did want to tell you what the wines are that are in front of you. So if you kind of look for your group number there, you should be able to determine which is which. And I'm going to do the same thing here. I will say I'm going to take the slide away in just a minute. So do kind of write down on your paper, write down somewhere which wine is which, or maybe put them in order so that as we talk about them, you can sort of reference back if you need to. Okay, so I'm going to go ahead and stop sharing my screen so that we can kind of get back. And I would say if you have kind of turned off your camera, if possible, we'd love to have you turn that back on so that we can participate. We can sort of talk together about things. As you're turning your cameras back on, Jenna, I think we do have this, I think it's time to launch that second poll. So we'll talk about all of your sensory impressions, but we do actually want a number for this one question. And that is whether or not you have a preference. So Jenna's going to go ahead and launch that poll of preference.
Just 1 second.
There you go. So this is a much simpler poll than the last one. Only one question. Which of the wines did you prefer? I guess I should ask this before I tell you what it is, but it's not technical data, so it's okay. Okay, last call. If you want to log your preference, if you're able to do that. Okay. Jenna, you can go ahead and end the poll. We're not going to look at the results quite yet. We'll talk about some other sensory impressions, and then we'll pull that up in just a minute. So, okay, so let's just kind of start by talking about whether this made a difference or not. Of course, that's the big question, right? Does it even make a difference? So, again, if you're able to put your camera on, what I'm going to ask you to do is just we're going to take a quick visual poll of how different did you feel like these wines were. A lot of times when we do a triangle test, we have a technical way of doing that. This one, because we have 3 wines, we couldn't do a triangle test. But I'm just going to ask you to kind of hold up your hand. If you felt like these wines were pretty much all the same, you're just going to give me that's on a scale of 1 to 5. 1 is going to be these wines were all the same. And 5 is going to be like these wines were very different. And it could just be if you feel like, 2 of them were the same and 1 of them was different. What's the whole range? Was the whole range large or was the whole range very small? So how different did these wines seem to you? Just go ahead and hold up hands. Okay, it's got some 3s, some 2s, and some 3s, and some 2s. It seems like you guys, this is what you do on your sensory sheets also. When I give you a scale of 1 to 10, you all of your numbers are like from 3 to 6. With one exception, there's one person that uses the whole scale. But okay, so it looked like it's kind of different and kind of not different. So for those of you that felt like there were some differences, what was different between the wines for you? What were some of those differences, even if they were small, that you were picking up? Again, this would be a good time to unmute yourself and just sort of to speak in. If you want to put something in the chat, I can see if I can see the chat. It's hard to see the chat, so let me see.
I can also read out the chat.
Okay, that would be great. So, anyone want to be brave? Somebody, what are some of the differences you can perceive between these?
Yeah, so I thought the 2 were pretty close and 1 was really different.
Okay.
The Noma cork for me was the one that really picked out. The one between the screw cap and the neutral cork, the difference was very, very low compared
Okay.
to
What
even
was
to-
different for you with the Noma cork? What seemed different to you?
I picked up a little bit of color difference, and also it was more like the aromatic intensity and the taste.
Was it more or less
Less.
intense? Less. Okay.
Yeah, like the screw cap and neutral work, that's the one I prefer. I thought they were the same almost because they were very similar. The Noma cork is really, I found out a little bit of color change, and the intensity and aromatic expression was not as good as the other ones.
Okay. Okay.
And that
Thanks,
kind of we
Damien.
see after on the graph that makes sense a little bit.
Right. Yeah, that would go like. So other impressions of that, did other folks feel like they kind of grouped that way? Did you have another impression of that?
From the chat, Vitor said that the Norma cork was the aromas are more intense.
Okay. Okay. So that one, again, the Noma cork stood out, but for him, the aromas were a little bit more intense. Okay. Other thoughts on the differences among these wines? What did you all think? I mean, that idea that like the Noma cork seemed to stand out from the other two, is that something that other folks picked up as well? I see some nodding.
Speak out, Kirsty.
I found that the Noma cork lacked the freshness that the other two seemed to have. It just seemed a little bit tired in comparison from the other two. I liked the color a little bit better, but I didn't like the much.
Okay. Was the color, what about the color? Was it just more intense, or was it a different like tint or something? What was it that you liked about the color?
It seemed a bit more yellow to me, and I don't know why I like yellow orange rosés, but I do.
You like the salmon peachy rosés?
I guess because all of the rosés that I make tend to have that color. That's kind of what I gravitate towards, perhaps.
It's familiar. Yeah. Okay. Other thoughts on the differences between these wines?
We have another comment from the chat. So I thought this was a triangle test, and the Noma cork stood out because of a slight color difference and a little more muted in aroma and flavors.
Okay. Okay. So it looks like, at least to some folks, that color difference that we picked up on in the numbers actually is something that might be perceptible, at least in some cases. So especially when we're looking very carefully at it. So, okay. Any other thoughts? When Jenna and I tasted this wine in the office when we were getting some samples ready, one of the first things that stuck out to me, and I don't know how much this translated when it got to you all, was that the wine seemed to have a real lively CO2 capacity component to it. And I did measure the CO2 both at bottling and each of these bottles when I opened them. So at bottling, the CO2 was at 2295. Which is pretty spritzy, but again, this was something that was very early bottling in December of the same year. And so that would make sense that it would have a fair amount of CO2. In the bottles that we tested in the office, the screw cap was at 1810, the neutral cork was at 1905, and the Noma cork was at 1650. So the Noma cork had lost a little bit more of the CO2 along the way as well, which makes sense. There's just more gas exchange happening in that particular cork. And so that might be a little bit of that contributor to freshness as well along the way. So, did anybody pick up any notes of oxidation or reduction, or was it like right now it's just at a nice fruity, happy stage? Anybody pick up any reduction?
No, I didn't pick up any either reduction or excess oxidation or something like that. It was a pretty pleasant wine. The three ones are pretty good. There's just, yeah.
Yeah.
And now that you say the CO2, it makes sense, because on the two other one that retain a lot more CO2, you can test that. That's what really brings the flatiness of the Noma cork, I think, with less CO2 makes sense in there. Yeah.
I mean, when I poured my little bottles, I could see bubbles in two of them. I mean, mine are not cooled, they're not chilled at all. So I think at room temperature, they're going to give it up, but like they even looked a little bit different there. So, of course I knew to look at it because I had measured it. So I'm not unbiased in this regard. Okay, well, let's look at our preference. So Jenna, do you want to show us what the preference turned out to be?
Sure. You'll have to tell me if you can see the results being shared.
I can see them. Can others see? Okay. So it looks like this it's almost well, I guess the NutriCork came in at 48%, the screw cap at 38%, and the NomaCork at 14%. And that would kind of go along the lines of what we were talking about. Were there any other elements that made you kind of want to prefer the wine that you did that we haven't talked about? Was there anything else that stood out to somebody in terms of that preference number? Other than the fact that one was a little more salmony color and Kirsty liked that better?
I mean, the difference between the screw cap and the neutral cork, the aglo, is very thin. I mean, for me,
Yeah.
I would have liked to put both of them because I like both of them. There is not one that stands out better than the other compared to the Noma cork. That's really different.
Yeah, I feel like if we had done a triangle test between those two, I think we probably wouldn't be able to tell the difference from, and we'll do that though. I mean, that's where your sensory statistics become really important, that because we didn't have a triangle test, we'll be able to determine, like, do these two kind of look the same all the time, and does this one look different in those different descriptors that you put on your sheets. So okay, Lee, so coming back to you, we were, the whole idea here was, what kind of a closure do you want to be using on this wine? So at this stage of the game, what are your thoughts?
Well, at this stage, I'm pretty glad to be moving a lot of my stuff away from the select greens anyway. If all things if it seems pretty equal, I would definitely think that I should be staying with screw cap for a wine like this. The one downside is that I think that Chamberson can be very prone to reduction, and I think that with any more time in the bottle, maybe you could see more evidence of that. So that's something I'd have to keep in mind if I continue to produce a wine exactly like this. We do make our rosé 100% out of Chamberson, in part because when we expanded our vineyard a number of years ago, we may have overplanted some Chamberson, and while I also like a nice orange salmony hued rosé, this is kind of what we have to work with. So but yeah, there's also just something nice about ease and lowering that threshold for people to get between them and their wine. So if you not everybody has 4 corkscrews in their truck like some of us do. So if you're able to lower that bar of entry, then that's probably a good thing.
Yeah. I think the one thing I think with screw cap in terms of logistics is that I don't think all of the bottling lines are able to do screw cap.
That's right.
Obviously Wine and Beer Supply can, and the Hunter line can, but I think right now Blue Moon, last I knew Blue Moon did not, but I don't know if they have that capability or not. So if you have an in-house bottling line, obviously it is a separate assembly to use. So but so that is one thing to keep in mind just in terms of logistics. But the other is, in terms of cost, the NomaCork was the most expensive one, not by much, but a little bit. And so if you're looking to have an affordable option that retains the quality of the wine, then that's a possibility. And I would just say, to your point about reduction, we will continue to age these in the office. And if after another year, it looks like there's some significant differences in sensory, we may get everybody back to these again in order to see if we've seen some of those effects. So it looks like we do have a question whether you inoculated with commercial yeast.
Yes, I did. I think I used bee fruits from Scott Labs.
Okay. And Caitlin did concur that Blue Moon does not have the ability to do screw caps right now. So if you are looking to integrate screw caps, just consider that as as is part of it if that's one of your bottling options. So, okay, anything else on this particular experiment before we move on to Kirsty's? Yes.
I just have a question about your sales strategy for the 3 different types of closures. Since you had a significant amount of each one, did you sell them at the same time, or did you sell one after the other? And if so, how are they received?
So I mentioned earlier that we have shiners available. So if anybody is interested in those, you know, and if you have a preference between the Aglo cork and the Noma cork, we can certainly talk about that. But yeah, we are just selling with screw cap in our tasting room.
Yeah, and Kirsty, I think that's a great question. Is how do consumers interact with these different bottles? Like, and maybe that's a question. There may be some data out there. I'll try to see if I can look at if there's been any consumer preference data on that. So
yeah, it seems that people look at our screw caps pretty favorably for the wines that we use them on. We use them on, you know, some of our sweeter wines and some of our you know, not the stuff that you want to age for 10 years, that sort of thing. So if you are looking to flip your inventory fairly quickly, and you're, you know, a lot of your SKUs are not things that you sell for a long time, then, you know, screw cap seems like a really good option.
okay, so with that, we'll go ahead and move on to another expert on screw caps, actually. So I'll welcome Kirsty to come and talk about her experiment a little bit. So this was an experiment looking at what's driving post-bottling SO2 depletion. So Kirsty, tell us a little bit about what your questions were moving into this study and what you wanted to find out for your own decision making.
Sure. I mean, I think as good winemakers, we always challenge. I think we know every year, and the one thing that I keep challenging myself at every time I go to bottle is where the free SO2 should be at bottling. And I was recently reminded by Joy that going into bottling, we shouldn't really need to worry about the antimicrobial properties of SO2 anymore, that we really should be worried about oxidation. I had a wine in a tank that got oxidized much faster than I thought. It was vintaged from one, you know, it was over vintaged from one harvest to the next, which I normally don't do, but it just got me thinking about SO2 levels, where they should be, what we should be thinking about. Traditionally, I try to target SO2 additions at bottling for a molecular, around 0.5 molecular. But again, after talking with Joy about perhaps we don't really need to do that for antimicrobial properties. It just really had me ask the question, where does the free SO2 need to be? So that's why I wanted to do this experiment.
And I love when Kirsty asks these questions that seem like very simple, straightforward questions, and it turns out that they're really complicated, hard to understand answers that it's not like there's a great answer in the literature. You know, the winemaking literature includes ideas of kind of what's binding to SO2 and what kind of things might be antimicrobial, but there's not a good answer to how fast is SO2 going to be, or free SO2 going to be depleted during aging, and what are the characteristics of the wines that might be driving that, or what do we need to think about in realizing that different wines kind of have different properties that way. So when we started this experiment, like I said, there wasn't a lot to go on, but we kind of thought we would just start by keeping track, by doing some measurements and trying to see if there were some trends that came out. I will say that there's some information that's been coming online in the last couple of years that has sort of helped to understand this a little bit better. So again, when we first started, the idea was just to kind of track what was happening with SO2 from the time of bottling through different time points during aging. Kirsty did choose 3 different wines to do that with. So we did this experiment with Gruner Veltliner, with Cabernet Franc, and with Painted White. So Kirsty, do you want to tell us just, you know, sorry, you just unmuted.
Sure.
You want to tell us just a little bit about kind of what type of wines these are, and particularly kind of what kind of bottle age or strategy you have in terms of kind of how long do you need these to stay fresh in the bottle?
Ideally, wine goes into the warehouse and comes out of the warehouse within a year. But with COVID changing things, it means that the wine is staying in the warehouse a little bit longer. So that's another reason I wanted to look at these experiments. But as a general rule, the Gruner Veltliner, the goal is a fairly mostly stainless steel, a little bit of barrel aged, but highly aromatic white wine that really should be sold and consumed with it in about 18 months of bottling. The painted white has more oak aging. It's really meant to be a fuller bodied white wine that has some aging potential. So ideally between 2 to 4 years in the warehouse. And then Cabernet Franc, the trend has been that is more towards the year in, year out. So we can bottle that and it's usually gone within about a year or 18 months of bottling. And that's where I feel comfortable. It's I would say a light to medium bodied red wine.
Great. So we'll keep that in mind too, as we kind of look at what these things are doing at the different time points that we have so far. So again, as we started this experiment, not a lot of information in the literature, but there were a couple of things that started to kind of come out to give us some things to start to think about. So the first was Dr. Sachs's paper looking at free bound and total sulfur dioxide during oxidation of wines. And if you were at the Virginia Wineries Association technical meeting a couple of years ago when Dr. Sachs came to talk, this was one of his talks. But if this is something that's interesting to you, I feel like that's one of the papers that I would that I'm drawing from a lot in thinking about this, and I would recommend that you check out. And then Dr. Waterhouse at UC Davis has also been kind of starting to look at this idea of a sulfur dioxide oxygen consumption ratio as some measure of wine oxidation. And again, if you've ever read one of Dr. Waterhouse's papers, they're brilliant, they're very detailed, and sometimes it's a little bit hard to get through all of the details of that. So what I will say is that right now, this is still very much a work in progress, but we're going to continue to think about these ideas. But for right now, we're going to kind of try to focus on the things that are pretty familiar for us to think about. But I would say that one of the things that's really shaped my thinking about this was a presentation given by Miaojing Xin at the American Society of Enology and Viticulture conference last year. And she had a talk called Measuring the Aging Capacity of Wine. And she's working out of Dr. Waterhouse's lab. And what she found was that she's trying to build this model that you can kind of measure ahead of time and decide how much oxygen or how much SO2 is going to get depleted based on all of these different measures of what's going into the wine itself. So the things that are currently in her model for being able to calculate this would be the free sulfur at bottling, which makes sense, right? The more free sulfur that you have at bottling, the more aging capacity the wine might have. The total package oxygen, which is what we talked about earlier. So the more oxygen that goes into the bottle, the less aging capacity that wine's going to have because it's going to oxidize presumably quicker. The type of closure that you're using, and specifically because of that oxygen transmission rate that contributes to oxidation. The amount of aging time, so the amount of sulfur dioxide that you need at the beginning depends on how long that you want to leave it in the bottle. So again, like for Kirsty, for the Gruner, that might be a different target than she would have for the painted white, because there's different target aging times for that. But then there was this other factor called the oxygen consumption capacity of the wine. And again, that's the thing that's still a work in progress, but we've actually started to work with Miao to try to understand how this is working. We've actually sent her some of Kirsty's wines. And so we're waiting to kind of see how that all sets out, but we might be able to delve into that a little bit more as these wines continue to age. But for today, we're really going to be talking about these other ones that are a little bit more familiar for us. So once again, this was an experiment that I happened to be there to take the samples for. Again, this is happening on a busy bottling day. So I basically would just go on the day that each of these wines was being bottled, and I would follow this protocol. So again, everything was coming from the same bottling tank, or coming from all of the samples we took were bottling from the same tank. So Gruner was one day bottled in April. Cab Franc bottled a couple of months later, and then painted white bottled in July. Kirsty uses the Hunter mobile bottling line, so all of these went through Jason's line. In this case, I took samples at 3 different time points. So I took early samples after sort of the first half pallet had gone through. I took samples right in the middle of the run as we calculated that based on the volume of the bottling tank. And then I took samples at the late in the run, and usually that was sort of the beginning of the last pallet. We wanted to get something that was representative of what was happening in the tank as the sort of volume of the tank went down, but we didn't want to get the last gurgles of the tank coming through the line, because that's really not representative of what's happening. For each of those, I would take 3 bottles at each of those time points and take my measurements. So in this case, I took measurements of dissolved oxygen. I was able to find a way to look at total package oxygen, which I'll explain to you in just a minute. And then we also took free and sulfur dioxide at bottling. Then we let these sort of age over time, and we continued to take dissolved oxygen, free and total sulfur, in triplicate, so 3 bottles at a time at different time points. So we definitely hit 1, 2, and 3 months for each of these wines. A couple of them we took a 4 months, some of them we didn't, and then we'll take them at 6 months, and then we'll continue this at 3-month increments moving forward, probably until we run out of wine. But that total package oxygen number is one that's a little bit hard to measure. So I'm going to tell you about how I measure that in just a minute. But there was one other thing about using the Hunter line here that I did want to show you. We did talk about how screw cap closures, Kirsty's bottling entirely under screw cap, and we talked about how screw cap sort of has a bigger headspace. But one of the other things in terms of total package oxygen when using screw caps is that when that screw cap is applied to the bottle, it's a cylindrical closure and there's air in there, and that air goes into your bottle. And so if that's just, atmospheric air that's going into the bottle, you're really introducing some oxygen along the way. No matter how well you sparge the headspace before you put that screw cap on, it brings some air with it. And I was talking to Jason about that after I was reading some things. I was talking to Jason about that when I was at Blenheim, and he was like, "Oh, well, we sparge under the screw cap." And I was like, "Please tell me more about this." And he sent me the pictures that you can see here. So in here, you can see this. This is kind of the sparging mechanism that they have on that line. And you can see, there's this one arm that's sparging nitrogen into the bottle after it's been filled. But then there's this other arm that comes off kind of at the side. And if we kind of look at where that arm is going, you can see it tucks up under the screw cap, and it's sparging under nitrogen under that screw cap before it's applied to the bottle. So in this way, this is sort of another bottling line QC measure that can be put in place in order to try to limit the nitrogen that's going into the bottle. I would also say, though, again, based on the AWRI audit, they were looking at big fancy commercial lines, and for the most part, they probably would have had all of the bells and whistles there, and they're still looking at about 60% of the total packaged oxygen still coming from the headspace. So it's important to keep that in mind as we go along. So then that comes to the total package oxygen number itself. So total package oxygen, as we saw before, was dissolved oxygen and the headspace oxygen, and then whatever coming in the closure. Most of our closures, we sort of have, the closures tend to be graded for that number. So we kind of have a number for that. Dissolved oxygen you can measure with the dissolved oxygen meter. But in order to measure headspace oxygen, it sort of takes this specialized sensor systems that's well beyond the scope of most wineries to be able to utilize for quality control. So when the AWRI did their audit, they wanted to come up with a way for winemakers to be able to do this if you choose to do it as part of your QC measures. So they kind of came up with this protocol to be able to measure total package oxygen without those sensors. And this is what you do. So you take some bottles from the bottling line at at some determined times. It does depend, your headspace oxygen is going to depend on the fill height. So you do want to basically measure the ullage and go from there. Then you take that bottle and you shake it up for 5 minutes. So you just kind of shake that bottle for 5 minutes. At the end of the 5 minutes, then you measure the dissolved oxygen and the temperature in the wine itself. And of course, that's gone up because you've integrated some of what was in the headspace into the bottle. That's not a direct integration, though. Not all of it has gotten into the bottle at that time. There's some partitioning coefficients to think about. But thankfully, AWRI thought about those for us, and they've provided this online total package oxygen calculator. So all you do is you kind of go in there and you plug and chug your fill height and your temperature and your volume and your dissolved oxygen. So in this case, it does require a dissolved oxygen meter, but it doesn't require the rest of those things. And I would say that if you don't have a dissolved oxygen meter, but you'd be curious about what these things are doing on your own bottling line, the Winemakers Research Exchange does have a dissolved oxygen meter, and I am happy to lend it out or to come and take those numbers with you or for you, and if that's something that you're interested in after the session today. Okay, so that's basically what we did here. So we're going to kind of look at what we saw for those 3 different wines, the Gruner, the Cab Franc, and the painted white. So first, when we looked at the dissolved oxygen for the Gruner, we're going to do this for all 3 of the graphs. Every time I show you this, the graph, the top graph is going to tell you what the dissolved oxygen was at bottling. And then after aging, we went ahead and took the dissolved oxygens at the same time we were taking the free and total sulfur. So we'll look at what's happening to that dissolved oxygen over time. So the Gruner itself at bottling, it started at in the tank, it measured at 1.15. But when we see this in the bottle, the early ones, which are shown by the green columns, the early and middle ones sort of have about the same amount of dissolved oxygen, which gets us at about 1.5. So there is a certain amount of pickup that's occurring there. That's about 0.4, still within kind of a normal range for what we would expect on a bottling line. You can see here that those later ones had a little bit higher dissolved oxygen, and that's kind of what we expect. As the fill of the tank goes down, more of the wine has sort of been closer to that boundary layer with the air above it. And it is pretty normal to see that uptick in dissolved oxygen as you go along. So if you are somebody that does QC on the bottling line, it is a lot of times we'll do that QC at the very beginning, but do realize that those numbers do oftentimes go up at the end as well. But then what's happening with that dissolved oxygen? Is that sort of oxidizing the wine over time? Well, if we look at the second graph here, after 3 months, most of that dissolved oxygen had been dealt with in the wine. So it was no longer dissolved oxygen. And that could either be by binding to different components in the wine, and it's certainly probably by binding to some sulfur dioxide as well. So in this case, Kirsty's Gruner is aging really without a lot of oxygen, at least that's showing up as dissolved oxygen here. Right here at 6 months, we start to see a little bit of an uptick there. And that might be our clue that oxygen transmission rate of the screw caps is starting to integrate enough oxygen that we're starting to see a little bit of an oxygen signature as we go. But the other thing that we measured for each of these wines was the free and total sulfur during aging. Now, as I said before, our free sulfur is going to tell us something about how much antioxidant protection is there in the wine. And again, it varies, but in the literature, kind of the rule of thumb is for white wines to be really safe against oxidation, you want to be above about 20 parts per million. And in this case, in Kirsty's Gruner, that's certainly the case. So we do see, let's see, it was bottled at about 30, I think it was at 32 or 33 milligrams per liter of free sulfur. By the end of the aging period, she's still, I think her average there was about 25 milligrams per liter. Well, you can also see that most of that decline happened in the first 2 months. Probably that's when the dissolved oxygen from the bottle was being consumed by the sulfur dioxide. And now the amount that it's changing over time, it's very low, and it probably is more governed by the oxygen transmission rate of the closure itself. But then if we want to look at sort of the total oxidation, that measure of larger oxidation over time, that's where our total sulfur comes in. We can see this bouncing around a little bit in those early months. That probably has more to do with just the limit of detection of the testing itself. But we can see that the total sulfur here started almost at 100, and now it's down a little bit below 80. So we do see that total sulfur is kind of going over time. So there is some oxygen that's being consumed along the way. So again, for this Gruner, if this is after 6 months, well, actually even after, it's a little bit longer than that at this point, we'll continue to look at these over time. But again, with that pretty, we'll look at total package oxygens in just a minute, but with the dissolved oxygen pretty much under control, again, after this amount of time at 33, bottling at 33 parts free, Kirsty's still in a pretty safe range right now. And again, if you kind of look at that, how much it's changing at this point, we almost could try to guess at how long before we started to see any oxidation. And I think you've got some time there. The second one that she looked at, that we looked at, was the Cabernet Franc. So again, the Cabernet Franc, the dissolved oxygen of the Cab Franc in the bottling tank was 0.24. So again, as I said, it's really easy. It's not that hard to manage dissolved oxygens in red wines. First of all, they're not as cold, so they don't have as much capacity to pick up dissolved oxygen. And the phenolics in the wine tend to quench that before it has any impact on the rest of it. In this case, throughout bottling, we can see we have a little bit higher at the very beginning and a little bit higher at the end, kind of a dip in the middle. Most of the kind of bottling audits will actually show this kind of a curve where you have a little bit more at the beginning because whatever's in the bottling line and whatever's in the lines and everything else, you're kind of flushing that out. So you have a little bit higher dissolved oxygen at the beginning. When you're really in the crux of it, you're just kind of cranking through, and then you don't have a lot of pickup through the line itself. And at the end, again, you get back to that boundary layer. But all of this is still well within normal parameters. Once again, if we look, I will say that the bottom graph here, the scale on the bottom is going to be different. We have a different number of months for each one of these because they're bottled at different times. So for the most part, for the Cab Franc, any dissolved oxygen that was there at bottling is pretty much gone by the time you get to about 2 months, which is consistent with what we saw with the Gruner. We do see a little bit of kind of uptick here. I think this thing at 4 months might have been an error on our part, and maybe our meter needed some attention or something. That might be an erroneous number, or we might just be starting to see a little bit more there. But again, we'll keep an eye on that to see if we start to see some of that building over time. When we look at the free and total sulfur here, this one, Kirsty, your target for reds must be lower, right? So this one, your free sulfur was like at 20 or 21, I think, at bottling.
Yeah, part of that was also I didn't want to futz with adding sulfur right before bottling, knowing that we were doing this experiment. And I know for a fact Cabernet Franc, by the time we sell out of one vintage, we're ready for the next. So of any of these 3 wines, this is the one that is the quickest to market.
Okay. Well, it turns out that was probably a really good decision. So if you look at your free sulfur is barely moving here. So, you started at 21, it was averaging at 19. And I will say for all of these free and total sulfur numbers, I've plotted the average here, but this is the average over 3 bottles for each one. So, so in this case, your free sulfur is barely moving. I will say that there's sort of the added wrinkle with determining free sulfurs on red wines that some of the SO2 is actually very loosely bound to anthocyanins. And so when we measure the free sulfur, some of what we're measuring as free sulfur isn't truly free sulfur. That was one of the things that Dr. Sachs's paper showed us. There's another paper that's looked at it to say that not truly free sulfur doesn't have any antimicrobial properties, but nobody's really looked to see if it has any antioxidant properties. So it's kind of hard to interpret what's happening there. And so once again, I think when we look at oxidation, that's where that total sulfur number is a little bit more helpful. And in this case, over the 6 months so far, the total sulfur started in the high 70s. Now it's kind of in the high 60s. So we do see some markers of oxidative, but it's very slow. And again, if this is a fast selling one, it makes sense that this would sort of be a little bit lower target to go through. Okay, and then the last one that we want to look at is the painted white. And so when we look at the painted white, this is one where, as you can see, the dissolved oxygen in the bottles was higher. This one and it seemed like it sort of got higher as we went through the day a little bit. So may have started at levels that would have been pretty acceptable along the way. But then as they kept going, those numbers got higher up to, above 2.5. In this case, this was actually the one day I wasn't there, Kirsty. I don't know if you remember, I was called away. And so you were pulling bottles. So I don't know if there was something, is there anything that comes to mind for you that might have been increasing your dissolved oxygens as you went through?
Not that I remember, but I'm quite surprised to see that they are as high as they are. That is concerning, but there was nothing that stands out in my memory as being different.
Okay. Yeah, and I think, it was a pretty warm day, but I don't remember anything, else about it than that. Right?
It was 100 degrees outside.
Yeah, it was. I do remember it was quite a warm day, and in that sense, I don't know. Like usually we would think about dissolved oxygen as like gases dissolving in liquid seems to actually be the warmer the wine is, the less it will actually take up oxygen. But it may be that the air was warm and the wine was cold. I'm not exactly sure how to interpret that. But I would also say that, you know, if you are somebody who's actively monitoring dissolved oxygen on your bottling line, but you're only taking a sample early in the bottling run, it is a reminder that things can happen as the day progresses that might change things along the way. Well, the other thing we can see here is I will point out on the second graph that on our other graphs we had a little bit more time for these numbers. So like the furthest right set of bars on the other ones were at 6 months. This one is only up to 3 months because that's as much monitoring as we've done on these so far. But what we can see is that it is taking, you know, that dissolved oxygen is showing up in the bottle, at least for the first couple of months. It does look like by the 3rd month, we're starting to see some lower levels. And I would anticipate as we look at 6 months, we might sort of see a little bit lower. But again, at this point, that oxygen transmission from the screw cap is coming in as well. The other thing that we can see on this wine is that this is the one that we saw more free sulfur depletion, and that kind of makes sense as well. So this one, again, bottled at about 33 parts per million. Now on average, I think it's down to about 23. So in that sense, having just a little bit extra security on the front end means that it's hopefully helpful here, and hopefully we'll see that kind of leveling off now that total package oxygen has sort of been dealt with a little bit by the free sulfur. So the other thing then is to look at that total package oxygen number. So far I've only been showing you dissolved oxygens. If I sort of take the numbers that I got off the line and do some averages, what we can see is that for the Gruner and the Cab Franc, the headspace oxygen made up about 53 or 55% of the total package oxygen. For the Gruner, or I'm sorry, for the painted white, it was a little bit less, but that's probably because the dissolved oxygen itself was a little bit higher, so it just sort of shifted the proportion. So again, if you're people that are kind of doing that QC on the line and you're just measuring dissolved oxygen, do realize that headspace oxygen makes a significant impact on the total package oxygen that you have. So Kirsty, let's if we kind of go back then before we wrap up, kind of are we getting close to answering your questions? Has this helped at all? What additional questions do you have at this point?
Yeah, it's helping, but I still think it's something that I will continue to look at, and I'm really curious to see how these wines do throughout the course of this aging. Part of what piqued my interest is when we looked at those older screw cap wines last year or the year before, and saw that after 7 years, you know, some of the wines still had SO2s that were making them taste fresh, and some completely had oxidized. So it's still a question that's on my mind. I don't think I feel comfortable saying, yes, I've figured it all out. So it's still to be determined. And I think I don't monitor dissolved oxygen on bottling day at all, or at least haven't until these experiments. It definitely makes me think about potentially looking at dissolved oxygen, especially those painted white oxygen numbers. Those are concerning. I didn't really know what to anticipate. I think Hunter does a great job of bottling, but if there's a loose clamp or, you know, a hole in a line somewhere, I think there's just the things you don't know what you don't know. So
yeah, I think that, and I think for me, when I looked at these data, that was the first thing that came through. Is even, you know, when I worked at Wineworks and we did a lot of QC on the bottling line, you know, I wasn't always checking later in the run, unless it was one of those days that we were running all day long on the same, you know, one big massive thing that I would check. But I would agree that sometimes you just don't know, and sometimes then you'll have these wines aging in a different way, some of them staying fresh and some of them not, and kind of not knowing. So hopefully at least that piece of it is informative, and sometimes too knowing what to look for there to say, oh, I need to go through, if I have this number, I need to go through and check where the oxygen might be coming in. So how about others? Any other thoughts that you all have after looking at this? I think Damien looks like he wants to say something.
Yes. So it's mainly, Kirsty, your question was like, do you add enough sulfur, or your question is like, do you have enough level, or do you want to add more or less, depend of?
I think it was a question. It was a question, a real question. Do I have too much? Do I have not enough? Does it depend on the wine style? So it was really because I like to have a definite number. So that's why I always use 0.5 molecular, because I knew regardless of the pH of the wine, regardless of the wine, I knew if that was my target, then I could figure it out.
Yep.
I think part of the challenge is that this sort of tells me that there's not one answer for everything, which is annoying because I really like to have one goal or one target. So it was mostly, I do feel like I bottle at free SO2s that are higher than a lot of people that I've talked to. So I was curious, am I too high? Yeah, it was really just to understand where I am and where I should be.
There is one thing I've asked this question for myself so many times also, and really unsure, but after I looked at some of the legislation, for example, in France that they have, and between, like, for reds, they are giving you a target between 20 and 25 ppm of free sulfur. If you're higher, sometime in a certain appellation, your wine can be declassified. So they've done those experimentation first in the term of how many sulfur you add right before bottling, because it's going to impact also your aromatic, a little bit. And for white and rosé, they say between 30 and 35 ppm. So that's why when you look at your numbers, I think you're right into the, and that's, I'm usually using the same, a little bit less for reds maybe, but for whites, I like to be at 30. But I think also it depends on the year. If you have a good year with good quality grapes, you're going to have you're going to need less sulfur than if it's a bad year like 2018, where you need to put a little bit more. That's in my head, but I think you variate the level depend of the year and the quality of harvest we had. I think.
And you think that's because there's other things for the SO2 to bind in a crummy year?
For sure.
And I think that some of that too gets back to doing your SO2 additions before you get to bottling. So Damien, to get back to like a 2018, I would suspect that we had, if we looked, even like 3 months after the wine was made, well before bottling, I would suspect that the ratio of free to total sulfur, that you would have a higher bound fraction than free fraction in those wines overall, which is why you probably need to add less sulfur in a good year. You just have less of the things binding it up, both in bulk aging and when you're in the bottle itself. I did also want to say, with reds, to get back, it's very interesting, Damien, those numbers from France, because we were using this number of kind of above 20 parts per million for whites to prevent or to sort of avoid oxidation. For reds, that number is about 10. So that would sort of go along with what you're saying, is that if your closure is sound, the amount that you would expect in terms of depletion over time would sort of age you to a point where, at a certain point, you can go quite a ways and still stay sort of above that number of 10 parts per million. And again, in reds, that's really just because your tannins are doing so much of the work of antioxidants at the time.
And that's why even that dose that they recommend, like, it's certain, like, appellation in France, they tell you between 20 and 25. But I know for me, with 10 and 15 at bottling with reds, I'm good. I'm usually good too. And like the total sulfur, that's another number that's interesting. For something, it's in Europe, but the legislation, it's like 150 total for the reds and 200 for the whites. That's what they recommend things. So, I mean, your numbers were really good on that, Kirsty, I have to say.
Not on purpose.
So I see a really good question in here from Caitlin about using the free sulfur chart that uses sort of the pH. So many of it, and I wish I had it on my slides because I think we would all immediately recognize it, but really that's looking at the molecular sulfur. So in that case, that goes back to that idea of which of the different functions of SO2 are we looking to utilize here? So when you're aging your wines in the cellar, thinking about molecular SO2 is important if you want to get antimicrobial function out of that SO2. So especially for our whites and sometimes for our reds, a target between 0.6 and 0.8 molecular SO2 is going to be helping with that antimicrobial function. Once you kind of sterile filter your wines through the bottling line, you theoretically shouldn't have to worry about microbes anymore. So in that case, you're really just thinking about the antioxidant part of that, which means that maybe you can get away with a little bit lower SO2 than what you would need to have to be fully antimicrobial in the bottle. I think that's especially important in our red wines where we have higher pH and therefore would need a higher free sulfur to get to that target for molecular sulfur. So that's a really good question to ask and an important distinction to make in terms of kind of how we're choosing those targets. Now, if you're bottling without filtration, then you have a whole nother kind of set of things to think about with regard to antimicrobial. But again, you kind of need to remember that you're going to lose free sulfur in the bottle as you age. So it's not always going to be there to protect you, even if you start at an antimicrobial, a number of like 0.6 or 0.8 molecular. So that's a really great question. So other thoughts or reflections about target SO2s at bottling and what might be causing this to happen? So Damien looks like he's got more to say. So go ahead, Damien.
I always have something to say.
It's okay.
But that was more a question about Lee, about the rosé. I didn't have the time, but he was talking about the color and the addition of free sulfur that was close to 50 ppm of free sulfur before bottling. Did you see, like, when you add your sulfur of 50 ppm just before bottling, a change of the color? Does it affect your color a little bit, or do you see more of an orangey color after the addition, or it doesn't change at all with Chambourcin?
So I would have added, I think, 40 parts at press when we are settling the juice and everything, and then so I didn't know that we were going to be bottling it so fast, but typically what I'll do is if my reds are done with mallow, or if my whites are done with alcoholic fermentation, and then I'm going to have them age for months to next summer or something like that, I'll usually hit it with like 100 parts, like just right off the bat, as opposed to adding 40 parts and then a month later finding that my rosé is going through mallow, or that whatever. So rather than just kind of making micro additions, just hitting it up front. So that's what we did after alcoholic fermentation. We would have hit it with about 100 parts. So that's why you have that higher total at about 148, 150.
No, but I think the total you're still good. It was more about the free, like when you still had like 50 ppm of free sulfur just before bottling, or at bottling, I guess.
I don't think we made any last minute additions on this one. Yeah, okay. Yeah. I also don't like to fuss with stuff too much, like right before bottling. Whenever you make those last minute decisions, sometimes they're made in haste, and then you end up course correcting something that didn't need to be done. And so we try to not do that. And this one was bottled fast enough we didn't have time to think about it too much.
Yeah.
One other thing too about those relatively large adds right before bottling, there are studies that show that additions, I think it's bigger than 10 parts per million within a couple of days of bottling, actually causes yeast cells to shrink, which means that they would be more likely to sneak through your filters. And so it's a better idea to kind of try to get your sulfurs within target, maybe a week ahead of time, and then just do small little fine tuning adjustments at the very end there. So I do want to honor your time. So I'm going to give kind of like a 1 minute kind of summary. And then if anybody has additional questions or wants to stay on and talk some more, we can do that. But if we kind of want to just do kind of a review of where we were today, we did talk about how the wine closure may have an impact on both your total package oxygen, but also those sensory characteristics of the wine. We talked about how screw caps have more headspace and therefore more potential for total package oxygen. We also very much saw how the synthetic closures have higher oxygen transmission rates, and in our case, saw some impact on the sensory for that reason. Those higher OTRs, we did also see lower SO2s and the color shift, both in the numbers and in the sensory. We talked just a little bit about the reductive potential. In this case, that wasn't an issue, which is a good thing, but it is something to keep in mind as you think about your closures. And then also we did see how the dissolved oxygen and therefore eventually the total package oxygen were higher when there were stops along the bottling line. And that would, again, be the same thing if you're bottling really slowly. So just keeping that in mind. And then we also looked at how the total package oxygen during bottling was what was a potentially good predictor of, or at least one of the predictors that Kirsty could use, or any of us could use, to think about how much of that SO2 we're going to be losing over time, and kind of getting to know those parameters to adjust what that target SO2 is at bottling itself. So with that, I'm just going to say thank you all so much for coming today. Thanks for doing your sensory sheets. Thanks for participating in the polls and the discussion. We want to make sure to thank the Virginia Wine Board for funding the Winemakers Research Exchange. We're very grateful for that. And also many thanks to Lee from Bluestone and to Kirsty from Blenheim for doing these experiments and being willing to share their wines with us along the way. Please do feel free to stay on if you have additional questions or comments. In the next week or so, we'll kind of put the video itself will be up on the website, but we'll also try to follow up with a newsletter that has some references to the things we've talked about today and a couple of past experiments along these lines as well, in case that's something that you're interested in delving more deeply into. And again, if anybody's interested in doing kind of a dissolved oxygen audit during bottling, I'm happy to talk to you about using the WRE dissolved oxygen probe if it's available. So thanks so much, everybody, and we will see you again next time, hopefully.